Forensic science is the application of science to criminal and civil laws. Forensic scientists collect, preserve, and analyze scientific evidence during the course of an investigation. While some forensic scientists travel to the scene to collect the evidence themselves, others occupy a laboratory role, performing analysis on objects brought to them by other individuals. In addition to the laboratory role, forensic scientists testify as expert witnesses in both criminal and civil cases and can work for either the prosecution or the defense. While any field could technically be forensic, certain sections have developed over time to encompass the majority of forensically related cases. Etymology. The word forensic comes from the Latin term forensis, meaning of or before the forum. The history of the term originates from Roman times, during which a criminal charge meant presenting the case before a group of public individuals in the forum. Both the person accused of the crime and the accuser would give speeches based on the sides of the story. The case would be decided in favor of the individual with the best argument and delivery. This origin is the source of the two modern usages of the word forensic, as a form of legal evidence and as a category of public presentation. In modern use, the term forensics in the place of forensic science can be considered correct, as the term forensic is effectively a synonym for legal or related to courts. However, the term is now so closely associated with the scientific field that many dictionaries include the meaning that equates the word forensics with forensic science. History. Early methods. The ancient world lacked standardized forensic practices, which aided criminals in escaping punishment. Criminal investigations and trials heavily relied on forced confessions and witness testimony. However, ancient sources do contain several accounts of techniques that foreshadow concepts in forensic science that were developed centuries later. For instance, Archimedes invented a method for determining the volume of an object with an irregular shape. According to Vitruvius, a votive crown for a temple had been made for King Hiero II, who had supplied the pure gold to be used, and Archimedes was asked to determine whether some silver had been substituted by the dishonest goldsmith. Archimedes had to solve the problem without damaging the crown, so he could not melt it down into a regularly shaped body in order to calculate its density. Instead, he used the law of displacement to prove that the goldsmith had taken some of the gold and substituted silver instead. The first written account of using medicine and entomology to solve criminal cases is attributed to the Book of Shi Yuan Lu, written in China by Song Si in 1248, during the Song dynasty. In one of the accounts, the case of a person murdered with a sickle was solved by an investigator who instructed everyone to bring his sickle to one location. Flies, attracted by the smell of blood, eventually gathered on a single sickle. In light of this, the murderer confessed. The book also offered advice on how to distinguish between a drowning and strangulation, along with other evidence from examining corpses on determining if a death was caused by murder, suicide or an accident. Methods from around the world involved saliva and examination of the mouth and tongue to determine innocence or guilt, as a precursor to the polygraph test. In ancient India, some suspects were made to fill their mouths with dried rice and spit it back out. Similarly, in ancient China, those accused of a crime would have rice powder placed in their mouths. In ancient Middle Eastern cultures, the accused were made to lick hot metal rods briefly. It is thought that these tests had some validity since a guilty person would produce less saliva and thus have a drier mouth. The accused would be considered guilty if rice was sticking to the mouths in abundance or if the tongues were severely burned due to lack lack of shielding from saliva. Origins of forensic science in 16th-century Europe. Medical practitioners in army and university settings began to gather information on the cause and manner of death. Ambroise Paré, a French army surgeon, systematically studied the effects of violent death on internal organs. Two Italian surgeons, Fortunato Fidelis and Paolo Zacchia, laid the foundation of modern pathology by studying changes that occurred in the structure of the body as the result of disease. In the late 18th century, writings on these topics began to appear. These included a treatise on forensic medicine and public health by the French physician François-Emmanuel Foderet and the complete system of police medicine by the German medical expert Johann Peter Frank. As the rational values of the Enlightenment era increasingly permeated society in the 18th century, criminal investigation became a more evidence-based, rational procedure minus the use of torture to force confessions was curtailed, and belief in witchcraft and other powers of the occult largely ceased to influence the court's decisions. Two examples of English forensic science in individual legal proceedings demonstrate the increasing use of logic and procedure in criminal investigations at the time. In 1784, in Lancaster, John Toms was tried and convicted for murdering Edward Culshaw with a pistol. When the dead body of Culshaw was examined, a pistol wad found in his head wound matched perfectly with a torn newspaper found in Toms's pocket, leading to the conviction. In Warwick in 1816, a farm labourer was tried and convicted of the murder of a young maidservant. She had been drowned in a shallow pool and bore the marks of violent assault. The police found footprints and an impression from corduroy cloth with a sewn patch in the damp earth near the pool. There were also scattered grains of wheat and chaff. The breeches of a farm labourer who had been thrashing wheat nearby were examined and corresponded exactly to the impression in the earth near the pool. Toxicology and ballistics. A method for detecting arsenious oxide, simple arsenic, in corpses was devised in 1773 by the Swedish chemist Carl Wilhelm Scheele. His work was expanded in 1806 by German chemist Valentin Ross, who learned to detect the poison in the walls of a victim's stomach. James Marsh was the first to apply this new science to the art of forensics. He was called by the prosecution in a murder trial to give evidence as a chemist in 1832. The defendant, John Bodle, was accused of poisoning his grandfather with arsenic-laced coffee. Marsh performed the standard test by mixing a suspected sample with hydrogen sulfide and hydrochloric acid. While he was able to detect arsenic as yellow arsenic trisulfide, when it was shown to the jury it had deteriorated, allowing the suspect to be acquitted due to reasonable doubt. Annoyed by this, Marsh developed a much better test. He combined a sample containing arsenic with sulfuric acid and arsenic-free zinc, resulting in arsine gas. The gas was ignited, and it decomposed to pure metallic arsenic, which when passed to a cold surface, would appear as a silvery black deposit. So sensitive was the test, known formally as the Marsh test, that it could detect as little as 1/50th of a milligram of arsenic. He first described this test in the Edinburgh Philosophical Journal in 1836. Henry Goddard at Scotland Yard pioneered the use of bullet comparison in 1835. He noticed a flaw in the bullet that killed the victim and was able to trace this back to the mold that was used in the manufacturing process. Anthropometry. The French police officer Alphonse Bertillon was the first to apply the anthropological technique of anthropometry to law enforcement, thereby creating an identification system based on physical measurements. Before that time, criminals could only be identified by name. A photograph. Dissatisfied with the ad hoc methods used to identify captured criminals in France in the 1870s, he began his work on developing a reliable system of anthropometrics for human classification. Bertillon created many other forensics techniques, including forensic document examination, the use of galvanoplastic compounds to preserve footprints, ballistics, and the dynamometer, used to determine the degree of force used in breaking and entering. Although his central methods were soon to be supplanted by fingerprinting, his other contributions like the mugshot and the systematization of crime scene photography remain in place to this day. Fingerprints. Sir William Herschel was one of the first to advocate the use of fingerprinting in the identification of criminal suspects. While working for the Indian Civil Service, he began to use thumbprints on documents as a security measure to prevent the then rampant repudiation of signatures in 1858. In 1877 at Hooghly, Herschel instituted the use of fingerprints on contracts and deeds, and he registered government pensioners' fingerprints to prevent the collection of money by relatives after a pensioner's death. In 1880, Henry Faulds, a Scottish surgeon in a Tokyo hospital, published his first paper on the subject in the scientific journal Nature, discussing the usefulness of fingerprints for identification and proposing a method to record them with printing ink. He established the first classification and was also the first to identify fingerprints left on a vial. Returning to the UK in 1886, he offered the concept to the Metropolitan Police in London, but it was dismissed at the time. Faulds wrote to Charles Darwin with a description of his method, but, too old and ill to work on it, Darwin gave the information to his cousin, Francis Galton, who was interested in anthropology. Having been thus inspired to study fingerprints for 10 years, Galton published a detailed statistical model of fingerprint analysis and identification and encouraged its use in forensic science in his book, Fingerprints. He had calculated that the chance of a false positive was about 1 in 64 billion. Juan Vucetich, an Argentine chief police officer, created the first method of recording the fingerprints of individuals on file. In 1892, after studying Galton's pattern types, Vucetich set up the world's first fingerprint bureau. In that same year, Francisque Rojas of Necochea was found in a house with neck injuries whilst her 2 sons were found dead with their throats cut. Rojas accused a neighbor, but despite brutal interrogation, this neighbor would not confess to the crimes. Inspector Alvarez, a colleague of Vucetich, went to the scene and found a bloody thumb mark on a door. When it was compared with Rojas' prints, it was found to be identical with her right thumb. She then confessed to the murder of her sons. A fingerprint bureau was established in Calcutta, India, in 1897, after the Council of the Governor-General approved a committee report that fingerprints should be used for the classification of criminal records. Working in the Calcutta Anthropometric Bureau, before it became the Fingerprint Bureau, were Azizul Haq and Hemchandra Bose. Haq and Bose were Indian fingerprint experts who have been credited with the primary development of a fingerprint classification system, eventually named after the supervisor, Sir Edward Richard Henry. The Henry classification system, co-devised by Haq and Bose, was accepted in England and Wales when the first United Kingdom Fingerprint Bureau was founded in Scotland Yard, the Metropolitan Police Headquarters, London, in 1901. Sir Edward Richard Henry subsequently achieved improvements in dactyloscopy. In the United States, Dr. Henry P. D. Forrest used fingerprinting in the New York Civil Service in 1902, and by December 1905, New York City Police Department Deputy Commissioner Joseph A. Forot, an expert in the Bertillon system and a fingerprint advocate at police headquarters, introduced the fingerprinting of criminals to the United States. Uhlenhuth test. The Uhlenhuth test, or the antigen-antibody precipitant test for species, was invented by Paul Uhlenhuth in 1901 and could distinguish human blood from animal blood, based on the discovery that the blood of different species had one or more characteristic proteins. The test represented a major breakthrough and came to have tremendous importance in forensic science. The test was further refined for forensic use by the Swiss chemist Maurice Müller in the 1960s. DNA fingerprinting was first used in 1984. It was discovered by Sir Alec Jeffreys, who realized that variation in the genetic code could be used to identify individuals and to tell individuals apart from one another. The first application of DNA profiles was used by Jeffreys in a double murder mystery in a small England town called Narborough, Leicestershire in 1983. A 15-year-old schoolgirl by the name of Linda Mann was raped and murdered in Carlton Hayes Psychiatric Hospital. The police did not find a suspect but were able to obtain a semen sample. In 1986, Dawn Ashworth, 15 years old, was also raped and strangled in a nearby village of Enderby. Forensic evidence showed that both killers had the same blood type. Richard Buckland became the suspect because he worked at Carlton Hayes Psychiatric Hospital, had been spotted near Dawn Ashworth's murder scene and knew unreleased details about the body. He later confessed to Dawn's murder but not Linda's. Sir Alec Jeffreys was brought into the case to analyze the semen samples. He concluded that there was no match between the samples and Buckland, who became the first person to be exonerated using DNA. Jeffreys confirmed that the DNA profiles were identical for the two murder semen samples. To find the perpetrator, DNA from entire male population, more than 4,000 aged from 17 to 34, in town was collected. They all were compared to semen samples from the crime. A friend of Colin Pitchfork was heard saying that he had given his sample to the police claiming to be Colin. Colin Pitchfork was arrested in 1987 and it was found that his DNA profile matched the semen samples from the murder. Because of this case, DNA databases came into being. There is the national and international databases as well as the European countries. These searchable databases are used to match crime scene DNA profiles to those already in database. Maturation. By the turn of the 20th century, the science of forensics had become largely established in the sphere of criminal investigation. Scientific and surgical investigation was widely employed by the Metropolitan Police during the pursuit of the mysterious Jack the Ripper, who had killed a number of prostitutes in the 1880s. This case is a watershed in the application of forensic science. Large teams of policemen conducted house-to-house inquiries throughout Whitechapel. Forensic material was collected and examined. Suspects were identified, traced and either examined more closely or eliminated from the inquiry. Police work follows the same pattern today. Over 2,000 people were interviewed, upwards of 300 people were investigated, and 80 people were detained. The investigation was initially conducted by the Criminal Investigation Department, headed by Detective Inspector Edmund Reed. Later, Detective Inspectors Frederick Aberline, Henry Moore, and Walter Andrews were sent from Central Office at Scotland Yard to assist. Initially, butchers, surgeons and physicians were suspected because of the manner of the mutilations. The alibis of local butchers and slaughterers were investigated, with the result that they were eliminated from the inquiry. Some contemporary figures thought the pattern of the murders indicated that the culprit was a butcher or a cattle drover on one of the cattle boats that plied between London and mainland Europe. Whitechapel was close to the London docks, and usually such boats docked on Thursday or Friday and departed on Saturday or Sunday. The cattle boats were examined, but the dates of the murders did not coincide with a single boat's movements, and the transfer of a crewman between boats was also ruled out. At the end of October, Robert Anderson asked Police Sergeant Thomas Bond to give his opinion on the extent of the murderer's surgical skill and knowledge. The opinion offered by Bond on the character of the Whitechapel murderer is the earliest surviving offender profile. Bond's assessment was based on his own examination of the most extensively mutilated victim and the post-mortem notes from the 4 previous canonical murders. In his opinion, the killer must have been a man of solitary habits, subject to periodical attacks of homicidal and erotic mania, with the character of the mutilations possibly indicating satyriasis. Bond also stated that the homicidal impulse may have developed from a revengeful or a brooding condition of the mind, or that religious mania may have been the original disease, but I do not think either hypothesis is likely. Handbook for Coroners, Police Officials, Military Policemen was written by the Austrian criminal jurist Hans Gross in 1893, and is generally acknowledged as the birth of the field of criminalistics. The work combined in one system fields of knowledge that had not been previously integrated, such as psychology and physical science, and which could be successfully used against crime. Gross adapted some fields to the needs of criminal investigation, such as crime scene photography. He went on to found the Institute of Criminalistics in 1912 as part of the University of Graz Law School. This institute was followed by many similar institutes all over the world. In 1909, Archibald Rees founded the Institut de Police Scientifique of the University of Lausanne, the first school of forensic science in the world. Dr. Edmond Locard became known as the Sherlock Holmes of France. He formulated the basic principle of forensic science: every contact leaves a trace, which became known as Locard's exchange principle. In 1910, he founded what may have been the first criminal laboratory in the world, after persuading the police department of Lyon to give him 2 attic rooms and 2 assistants. Symbolic of the newfound prestige of forensics and the use of reasoning in detective work was the popularity of the fictional character Sherlock Holmes. Written by Arthur Conan Doyle in the late 19th century, he remains a great inspiration for forensic science, especially for the way his acute study of a crime scene yielded small clues as to the precise sequence of events. He made great use of trace evidence such as shoe and tire impressions, as well as fingerprints, ballistics and handwriting analysis, now known as question document examination. Such evidence is used to test theories conceived by the police, for example, or by the investigator himself. All of the techniques advocated by Holmes later became reality, but were generally in their infancy at the time Conan Doyle was writing. In many of his reported cases, Holmes frequently complains of the way the crime scene has been contaminated by others, especially by the police, emphasizing the critical importance of maintaining its integrity, a now well-known feature of crime scene examination. He used analytical chemistry for blood residue analysis, as well as toxicology examination and determination for poisons. He used ballistics by measuring bullet calibers and matching them with the suspected murder weapon. Late 19th, early 20th centuries figures. Hans Gross applied scientific methods to crime scenes and was responsible for the birth of criminalistics. Edmond Locard expanded on Gross' work with Locard's exchange principle, which stated, whenever 2 objects come into contact with one another, materials are exchanged between them. This means that every contact by a criminal leaves a trace. Locard was also known as the Sherlock Holmes of France. Alexander Lacassagne, who taught Locard, produced autopsy standards on actual forensic cases. Alphonse Bertillon was a French criminologist and founder of anthropometry. He used anthropometry for identification, saying each individual is unique and by measuring aspect of physical difference, there could be a personal identification system. He created the Bertillon system around 1879, which was a way to identify criminals and citizens by measuring 20 parts of the body. In 1884, there was over 240 repeat offenders caught through the Bertillon system. Fingerprinting became more reliable than the Bertillon system. 20th century later, in the 20th century, several British pathologists, Mikey Rochman, Francis Camps, Sidney Smith and Keith Simpson, pioneered new forensic science methods. Alec Jeffreys pioneered the use of DNA profiling in forensic science in 1984. He realized the scope of DNA fingerprinting, which uses variations in the genetic code to identify individuals. The method has since become important in forensic science to assist police detective work, and it has also proved useful in resolving paternity and immigration disputes. DNA fingerprinting was first used as a police forensic test to identify the rapist and killer of two teenagers, Linda Mann and Dawn Ashworth, who were both murdered in Narborough, Leicestershire, in 1983 and 1986 respectively. Colin Pitchfork was identified and convicted of murder after samples taken from him matched semen samples taken from the two dead girls. Forensic science has been fostered by a number of national forensic science-learned bodies, including the Chartered Society of Forensic Sciences, then known as the Forensic Science Society, publisher of Science and AMP Justice. American Academy of Forensic Sciences, publishers of the Journal of Forensic Sciences. The Canadian Society of Forensic Science, publishers of the Journal of the Canadian Society of Forensic Science. The British Academy of Forensic Sciences, publishers of Medicine, Science and the Law, and the Australian Academy of Forensic Sciences, publishers of the Australian Journal of Forensic Sciences.